All right, this quarter we're going to focus on reading files and writing to files, which is something you do in pretty much every programming language. Python makes it nice and easy, and it's very versatile. We can use it for different things. Here I've given you a list of Pokemon. It's just text. There's no fancy formatting. It's all caps. There's no fancy characters. I've even taken out the male and female thing on the Nidoran, for example. And my question for you today is, okay, E is the most common letter in English in general and most other European languages that use this alphabet. What's the second most common letter in the names of the Pokemon? Okay. Now, you could just look up what's the second most common letter in general, and you'll see a few candidates. Sometimes it's I, sometimes it's A. But remember that this is a sample that's not English in general. You might see different frequencies. For example, I bet there's a lot more K in here than there is in general. And if you're making signs for an Italian restaurant, you're going to use a lot more Z than you would in general. So we're looking at the frequencies in here, not just English. So first, we're going to open the file and read it, and then we're going to get that into a Python object that we can work with just like we've worked with everything else in the past. And the old way to do that is 3 steps. You'd go open, read, close. Let me show you that. Okay. Tradition says that we call a file F. Okay, so we go open Pokemon.txt, that's just the name. And since it's right next to it in the same folder, we don't need a path to say, okay, it's this folder, whatever. And then we could go, okay, f.read is a method that'll go into that and grab the whole thing, just all the characters in one big blob, no fancy stuff. And then we say f.close. And that would work. I can say print Pokemon, and as long as I didn't make any typos, that does load it into a Python object that we can work with. However, this has a couple problems. One is that if we get an error in the middle, anything between open and close, so if something goes wrong with the reading, maybe it hits a bad byte, or it goes too long and takes too much memory, or the computer has an issue, or if we put other stuff in between the open and close and that has an error, then it might not close, and that might leave our file in a bad state next time we try to open it. So we could add a bunch of error handling in here, try except, anticipate all the problems. However, the Python authors have given us a lovely shortcut which is called a context manager, and this is used for other things too. If we open up a connection to a database, we might use a context manager to say, hey, we've got this thing, it's open, if anything goes wrong, we're going to handle it, close it at the end, take care of it. So the way to do that, not really sure where this word came from, is with. Okay, if you say with some kind of connection that you're opening, then that is managed by Python. We give it a name, and then anything we put indented under there is taken care of. And at the end, it will close it. It's beautiful. We have one less line, sure, but the real benefit is the error handling. So now, if I print, it's going to be the same, but I have a more robust version that's going to be resistant to errors. And remember that you only put the reading in here. We don't put all our other code in this indented block because we want to keep it separate as quick as we can, get the job done, close the file, and then move on to our other stuff. So whenever you print this, it looks nice, but it's really one giant string that just has these things called the new line character. The new line character looks like that, and it's represented as a line break in here, but it's really just one big old string. Okay, if you want the lines, there's a method called readLines, which does, honestly, the better version of this. But for now, we're going with absolutely simple, classic read. Give me the whole thing all at once. If it's a giant file and it's too much, you don't want to have it all in memory at the same time, we might read, the first 100 lines or the first 1,000 lines, and then do the next chunk when we're done with that. So anyway, we want to find the common letters, and how do we do that? Well, it's definitely going to be a dictionary. It's going to be a dictionary because that's the way to map a key to a value. So A, how many A's? B, how many B's? C, how many C's? And we could make that on our own. We could say like counts equals dictionary, and then for letter in Pokemon. If it's in there, we bump it up. And if it's not, we started at 1 because we just found one. And that would work unless I made a mistake. Hey, look at that. It does work. It says B22, U35, because it made them in order. Like when you look at the Pokemon, B is the first letter you see, U is the next letter you see, and so on. So this has a couple issues, like it's hard to find the top because they're not sorted or anything. And if I'm looking for the most common, I might go, hey, A, there's 116, E, there's 170, but I might just miss one if I'm using my eyes. And another issue is that it includes other characters like an apostrophe and a dot. We really don't want those right now. So we could filter. We could say like, okay, filter. There's a method called isAlpha, meaning is an alphabetical character. And, well, you got to spell it right. And that'll take out the dot and the apostrophe and the space and whatever else was in there. So that's helping a little bit. But it's still not in order. Still a little bit ugly to have to make all this ourselves. And guess what? Python, they always have exactly what we need. There's a built-in data structure that does exactly this, even better. So we can go from collections, import counter. Counter is a dictionary that counts everything, does it in an efficient way, organizes it top to bottom, and it has extra helpful methods, like you say, hey, what's the most common? And it'll just tell you. You don't even have to look it up yourself. So I can say print counter of Pokemon, and it's going to count them all very nicely and efficiently. For example, let me show you one thing. I could make a comprehension. I could say letter, and then count letter, if I made this little dictionary here, that looks cool, and it's definitely shorter than what I wrote a minute ago, but it does more work than it should. It says B, I'm going to look for all the B's in the whole thing. U, I'm going to look for all the U's in the whole thing. L, I'm going to look for all the L's in the whole thing. So it loops through the whole thing many times, whereas the counter is more efficient. It says I'm going to loop through the whole thing one time and just keep track of multiple parallel counts, you know. So even though this looks cool and doing a dictionary comprehension is fun, it's not as efficient as the counter. And if you notice a minute ago when I did the counter, the winner was an ugly line break character. We don't really want to know about that, so I'll use the filter again maybe. Do I need parentheses? Hey, look at that. And it puts them most common to least. So E's at the top, which we assumed. E's the most common, pretty much always. And A was the second most. That's not bad. We've got, in English, sometimes A is the second most common letter. But like I said, it's not completely the same as English. K is pretty rare in English, whereas Pokemon use K quite a bit. And in other languages, it's even more dramatic. Like French pretty much never uses K at all. And you'll see like 1 or 0 if you had this many characters in French. So throughout this quarter, we're going to open up a file, read the stuff, do a little bit of filtering or counting or sorting or whatever, and then later we'll learn how to write on the file and save our progress for later or share it with another person, that kind of thing. Now, as you see, there's only 4 lines of code, but it takes a lot of thought behind it, and we can use these ideas to do bigger things later. There you go.